So this is section 5.1, and I want to determine the degree and leading coefficients, and then I want to describe the end behavior. What happens as I go to positive and then negative infinity? What happens to f of x? All right, so to figure out the degree and the lead coefficient, I'm looking at the factored form of f of x here, okay? So what I need to do to figure out the degree is look at the degrees of each of these individual terms here. When I look at this, x minus 5 has a multiplicity 3, so that's a degree 3. There's x minus 5 3 times, so that's 3 x's there. Okay, what's the multiplicity for this next one? It's 1, so that's a degree 1 term. And what's the multiplicity here? It's another 1 right there. So I have a degree 3, a degree 1, and a degree 1. So the total degree here is degree 5. Now, degree of f is degree 5. Now I want to do the lead coefficient. So to do this one, it's a little bit more, but it's not too much more. The lead coefficient, this is our biggest, baddest dude, all right? So I'm going to look at the biggest, baddest one in each parentheses here. So what's my biggest one here? It's my x, so that's a 1x. What's my biggest, baddest one here? It's a 2x. And what's my biggest, baddest one here? It's a negative x. Well, how many of these 1x's do I have? Well, I've got 3 of them, so that's cubed, okay? How many do I have here of my 2x? I've got 1 of them, so that's just 1. And then how many of my negative x? I've just got 1 there. So I want to multiply those terms together. Imagine if you multiplied all this out, you'd multiply all those terms together. So what is this? This is x cubed times 2x times negative x. Now, this is a 1, and 2 is 2, and then negative makes a negative 2. And then I have x, and x to the 3. That's x to the 5th. So this verifies that the degree is 5. And we've just muscled out the lead coefficient. The lead coefficient, this is equal to negative 2 here. Okay? So a little tricky, but all you really have to do is look at the lead term in each of these parentheses and then multiply them all together and look at how many copies there are of each of those and account for that. Okay? So describe the end behavior. Now f of x, as x gets really big, it's really going to look like that lead term, and that's why we spend so much time trying to figure out what is it. Now, it's negative 2x to the 5. Since it's an odd degree, odd means opposite. So either both one is going up, then that means the other has to go down, or if one is going down, the other side has to go up. So our question is, which one of these two scenarios is going on here? Well, how do I know which scenario? I look at the lead coefficient, okay? So odd tells me opposites. Even degree tells me the same. So if both are going up, or if one's going up, the other's going up. So since it's odd, it's opposites. Now, the negative 2 here, this tells me that I'm going down on the right-hand side. So the right-hand behavior, as x gets really big in the positive direction, okay, as x goes to positive infinity, my right-hand behavior is going down to negative infinity. So how do I write this? F of x goes to blank as x goes to infinity. I write negative infinity for my solution. Okay, but what about f of x goes to blank as x goes to negative infinity? So it's a fancy way to say, let's go left. So what happens as I go left? My f of x is going up to positive infinity. That's the left-hand behavior. This is the right-hand behavior here. Okay? So we don't know yet, what's going on here, if it wiggles or if it just goes straight down or what.